piecewise functions, because man, kids love piecewise functions. Heck, they barely understand functions. Now there's pieces of functions. All right, so let us get started. What should we do first here? Is the relation defined by the following piecewise rule a function? Explain. I always say a picture is worth a thousand words, so I think I'll just graph it. That way I can actually see what's going on. Now I know that this has a mother function of y equals x. I know it's a line, okay, same thing here. And I'm just going to plot 2 points and draw a line. It says x is less than 2, plug in a 2, plug in a 3. And even though you can't be 2, big deal, you can still plug one in. 2 times 7 is 14, take away 4 is 10. 3 times 7 is 21, take away 4 is 17. So I've got some pretty high points over here. To the right 2, and we'll just call this 10. And since I can't be that point because there's no equality, I'm just going to put an open circle. And then to the right 3, oh, why did I plug in a 3? Because I'm an idiot. Can't plug in a 3, it won't accept 3. I can plug in a 1. 7 minus 4 is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 3, be about right there. That's what the graph's doing there. And it's running forever. This says x is greater than or equal to 2. Make my table. Plug in a 2, I get back a negative 3. And if I plug in a 3, I get back a negative 2. So 2, negative 3, 1, 2, 3. That's a solid hole. 3, negative 2. Boy, I'm tired. Plug in a 2, get back 3. Plug in a 3, get back 2. I should probably just stop while I'm ahead. Really should. And that goes like that forever and ever. Is it a function? Yes. There is no gap in the domain. I don't know if you would have seen it here or not, but there is a gap. And for that matter, there's not even a gap in range. There's really not. There is no gap in the domain. There is no gap in the range, although that doesn't require, but it's definitely a function. And it's a function because every x value has an output. So there you go. Choose a function. Let's see, we've got some graphing here, but I'm not going to do any of that. At least not those. Number 6, you're given a function. You're asked to find out if it's increasing or decreasing on the interval from 2 to 7. Specifically, find the, and it should say, and I need to add that, find the average rate of change, because I want to know the actual number. So we have inputs of 2 to 7. That's going to happen here, because here x can be 2 to 7. All right. So I'm going to use my little formula for average rate of change, f of b minus f of a, sitting pretty over b minus a, and I'm going to go to town on it. The interval is 2 to 7, so after the side I find f of 2, which means I let x be 2, and that would return a 0. I also need to find f of 7. If I plug in a 7, that's going to be negative 10. And the 7 was f of b, so where b is, I'm going to plug in a negative 10. Take away 0. Sitting pretty over b minus a, 7 minus 2, and it is going to be negative 10 over 5, which is negative 2. So this is definitely decreasing. The slope, or the average rate of change, is negative 2. Just can't think right now. I'll do one of these. You're supposed to write the rule. I guess I'll do number 8. Why not? Looks like number 8. These aren't hard. These are lines. That's what they are. It's going to have three functions. F of x has three different pieces. And you talk about this left to right. There's this guy. And this guy is really simple. That's negative x. It crosses at the origin. It's got a slope of -1. It's negative x if the x values that I can have here are -3, less than or equal to x, less than or equal to 2. Notice there's no equality, sorry, -2. There's no equality on the -2 because there's an open hole. Then you got this dude right here. That's y equals 1 because anywhere on that little line segment, the y value is 1. And it is valid for -2 to 1. -2 less than or equal to x less than 1. The last thing you have is you have this little line segment, and I'm just kind of cheating here because they're not that bad. Oh, yeah, it's got, what does it do? It falls 4, runs 1. You know, if I kind of extrapolate out here, it hit down here at -5. And it has a slope of rise 4, run 1. So that is 4x minus 5. If the x value is stuck between 1 and 2 inclusive. So that's writing a piecewise function. Now what do we got on 9? Do one of these. Write the absolute value function f of x is 3x plus 1 as a piecewise defined function. I don't know if I should teach this with algebra or if I should teach it by graphing. I really don't know. Come to think of it. I do know I need to change that number on the inside. Make it a 9. So that needs to be edited. I think I'll graph it. Before I graph it, I have to pull the 3. This thing has been shifted left 3. And it has a slope equal to 3. So I gotta go left 3, and then I have to rise 3 and run 1. Now, when you do that, you can clearly see that this thing has two parts. It does. It's got two parts. You've got a left tail and a right tail, and they can both be thought of as lines. Both of them can. And it won't be too bad, actually. It's actually really easy. But anyways. Alrighty. So let's focus on this thing. What is that thing? Now that thing is falling 3 and running 1. If you could extrapolate that out there, if you fell 3 and ran 1, be right there. Fall 3 more and run 1, be right here. Fall 3 more and run 1, you'd be right here. It would be at 0, -9, if it continued. So what I know about this tail is it has a slope equal to -3 and has a y-intercept equal to -9. So this left-hand piece, there's its equation, mx plus b. I am -3x minus 9 for all values where x is less than 3. If you're like Milbrath, it's got a solid dot. I'll just take care of that on this one. They both can't be solid. You can only plug into one function. Now, the other one is actually pretty simple. And I'm doing this so I can kind of show you how you do this anyways. If you were to keep rising 3 and running 1, you'd be right there. You'd be at 0, 9. You'd have a slope of 3, a y-intercept of 9. So for the right-hand tail, you're 3x plus 9. It's really simple. Now, the reason I went over this, showing you the graph, was so that you'd understand what's happening. If you have the absolute value of 3x plus 9, what is trapped inside is 3x plus 9 or negative 3x minus 9. They're both the same distance from 0. That's how you do it. Because the absolute value, make it positive. All right? The reason I say this is trapped inside is because you could do something silly like this. You could do, all right, I could pull that negative 3. I could. And I could get rid of my symbolism. And I get the same equation back, wouldn't I? So that's what you end up with. They're actually really easy to do. There's 9. What else we got? There's a 10. You can figure that out yourself. Well, these are kind of interesting down here. Determine the range of each function below, and I only want to do 2 of them. That's all I want to do. And personally, I'd graph. I would graph it all day long. Make a table. I'm going to look at this function right here. It says less than 1. I'm going to throw in a 1 and 2, and I'll open hold a 1. If I throw a 1 at the thing, I've got 1 minus 1, which is 0. If I throw a 2 at this thing, I've got 2 minus 1, which is 1. So 0, 0 is a point on the grid, as is 2, 1. And I screwed up again. You can't plug in a 2. It takes things less than a 1. You can plug in a 0. If you plug in a 0, you get a negative 1. Just not feeling it today. 1, 0 would be right there. 0, negative 1 would be right there. And it runs left forever. It's almost like I got a case of vertigo here. That's open hold. Looks like that. So here's what I know about my range. It is negative infinity to something. You see that? Negative infinity to something. Now I'm going to see if this hole gets closed. I'm 3 minus x when x is greater than 2. It's not even a function. It's not. Well. So I'm going to throw in a table, I'm going to throw a 2 at it and a 3 at it. 3 minus 2 is 1. And remember, I couldn't actually be 2, so that's going to be an open circle. 3 minus 3 is 0. So if I throw a 2 at this thing, it returns 1 with an open circle. And if I throw a 3 at this thing, it returns a 0. And it'll do that forever. It looks like this. Well, this actually isn't so bad. While there is a jump here on your y values, they're accounted for over here. So this gap here doesn't really kill anything. It actually kills the domain a little bit. The range is going to be from negative infinity almost to 1. That's what she is, because what the left tail lacks, the right tail makes up for. I'm going to put in domain and range, so I'm going to change this now. The domain on this one, it would run from negative infinity all the way up to 1. And then it would run from 2 to infinity. So I'm going to throw that in. If you like your set builder notation, all values of x such that x is less than 1, your domain on this one, though, is going to have to be 2 parts. It is all values of x such that x is less than 1 or x is greater than 2. And there's a third way of writing this one. This one could also be all values of x is such a small thing such that x is not 1, 2, or 3. So it can be written a couple different ways. It's just really up to you. And I said I'd do 2 of these. I'll do 4. Maybe I'll redeem myself. Maybe I won't. We have k of x is x plus 2 if x is less than negative 2. So I'm just going to make my little table. I have x plus 2. I can throw a -2 and a -3 at it. Try not to make the same mistakes I've been making. If I throw a -2 at it, I get 0. If I throw a -3 at it, I get -1. So back to 0 with an open circle, back 3 down 1 with a closed circle. Looks like that. Then I have x plus 4 if x is greater than 1. This thing's got a heck of a gap, doesn't it? So I can feed it a 1 and I can feed it a 2. And again, I will open circle the 1. That's a 5, that's a 6. It looks like that. This one has got an issue with its range. There's a gap. There's nothing between 0 and 5. So the range is going to be -infinity to 0, not including because it's an open circle, union with 5 to infinity, or if you like your set builder, all values of y such that y is less than 0 or greater than 5. That works. The domain of this bad boy is going to be -infinity all the way up to -2, unioned with 1 to infinity. Or if you like your set builder notation, all values of x such that x is less than -2 or x is greater than 1. I don't know why, but I just got really drained, so I am done. Something happened. Anyways, there's your homework. Enjoy.